Processes, Session 2, Part 2. We're looking now at the building structure, particularly chasing, notching and drilling. So at the end of this part of the session, I want you all to be able to state the maximum depth of drill holes and notches. Also want you to be able to talk about the maximum depth of chases as well, which we looked at briefly in an earlier part of this section. Also want you guys to be able to explain why drill holes and notches can only be used in set areas, and also be able to say which areas they are, and state which building regulation covers the structure of a building. Okay, nice easy one. We're hitting that one right now, right at the start. Part A of the building regulations covers structure, and this is anything that might have an effect on the structure of the building would be explained in there. Excuse me. So notching, drilling and chasing are all covered in Part A of the building regulations if you need to find out more. But we're going to talk about them now. So firstly, we need to find out, well, what is a joist? Not everyone knows what a joist is. Joists are essentially these things here. What you'd find there. What is a notch? Well, a notch is a little chunk that's been cut out of a joist, and I think we all know what a drill hole is. We also need to understand why notches and drill holes can only be made in certain areas and to certain depths, and it's all to do with essentially protecting the structure of the property, stop it from cutting too far and potentially causing a collapse of the joist. We'd cut joists by hand, the wooden notches by hand. You could use a circular saw, you could use a hand saw, depends what you've got, what tools you've got essentially. So once you've cut it to the correct depth, you could then knock it out using a sharp chisel. Useful bit of kit to help with drilling would be a right angled drill. Let's get enough joist, so drill to through the joists, drill through the joists, yeah, and have the space to do that. You might use a hole saw, but you're more likely to use either an auger or a flat bit, sometimes known as a spade bit. I always used to call them a spade bit. Okay. Some of the key facts that we need to be aware of: never ever drill or notch through any joists that are less than 100 mm in depth. If you do that, then you're going to be putting the structure at risk of collapse. And there's only very specific sections of the joist that can be notched and specific parts which can be drilled, and we're going to look at the reasons for that now. And the reasons for that is there's lots and lots of different forces acting on the joist at all times. You get compressive forces, which are forces which push together, tensile forces, forces which pull apart, as well as shear forces, which are forces which act opposite to one another but not directly opposite. The best way to think about it is like a pair of scissors. Put shear force on the paper which causes it to shear, to cut. Yeah, because of this we can only notch and drill up in certain places and up to certain sizes. There's some places that you can't drill or notch, right? The exact centre of the span, that means this bit right in the middle here. What we do want to do whenever we drill, we want to make sure that we drill in the centre of the depth, okay? But we mustn't drill in the centre of the span. Okay, the span is the distance from edge to edge. The depth is the distance from top to bottom. Okay. Shear forces. Yeah, shear forces. You have shear forces in action just here, and as a result of that, we shouldn't make any notches or drill holes within the first 7% of the span. Calculation for that is 0.07 times the span in meters. So relative sizes of notches and drill holes will also differ depending on the effect of the forces on their shape. You can see with a hole, the forces are kind of acting evenly on all sides, whereas with a notch, the forces are essentially acting directly opposite each other, and as a result, you shouldn't put any notches past 1/4 of the span, 25% of the span. So you should notch within the first 25%, you would drill in the rest. Okay. So yeah, this essentially shows us where we can notch and where we can drill. Okay, so notch only in the first 25%, excluding the first 7%. Okay, or the first quarter is probably another way of saying it. So, we drill in the rest, apart from in the direct centre of the span. Okay. Like we looked at, a drill hole spreads the forces a bit better than a notch. So therefore, our drill holes can actually be bigger relative to the depth of the joist than notches. So the maximum size of a hole you can drill is 1/4 of the depth of the joist, which is formula is 1/4 of the depth, or depth divided by 4. Excuse me. Yeah, so for example, if the depth of the joist was 100 mil, you do 1/4 of 100, or 100 divided by 4, which would give us a maximum size of drill hole of 25 mil. Notches can be only 1/8 of the depth, so you do the depth divided by 8. In that case, if we were notching through a 100 mil joist, we do 100 mil divided by 8, which would mean the maximum depth of notch would only be 12.5 mil in this circumstance. If it was 100 mil depth joist. Another bit of key information: if you have two holes that you're going to drill next to each other, you should not drill them within 3 diameters of the largest hole between them. So say for example, you're drilling holes with a diameter of 20 mil. You drill one hole and you shouldn't drill the next hole within 60 mil of your other hole. Key bit of information: the width of both the drill holes and the notches should be big enough to give freedom of movement, because they will expand and contract. And quite often, if pipes are clipped too tightly against the joist as well, they will make sort of expansion and contraction noise as they heat up and cool down, as they expand and contract. Okay. So any cables passing through joists should also be protected, particularly if they're not at that maximum, the minimum depth, of 50 mil. So if cables are ran less than 50 mil from the surface, you need to make sure you give them appropriate protection from screws and nails. Now it is time for your task.